Hello guys, I'm sorry to say that I just missed one concept before going to the problems. That's the rolling of a body. So I'll start with discussion of the rolling of a body. Rolling body. You know that you are in translation motion. The velocity of the center of mass is v, and velocity of all the objects here is v. All the particles inside this object is v. It's the same for speed. This velocity of center of mass is v. Velocity of all the particles. If you're going in a train or a bus or a car or any vehicle, or even a plane, you can experience the same speed as the way as the speed and the acceleration the train or the system is moving. So all the particles inside this system experience the same velocity. But if it is rolling, not only the translation motion is acting on that object, not only translating motion is acting on that object, both translation motion and rotational motion is acting on that object. Because if a body is rolling, the body should now say, if it is at point A here, time t equals 0, and at time equals t1 at point B here, it has traveled a distance from this to that, take as d, right? And also, you can travel like this. If it rolls, it should have a velocity like this. So, a rolling body is a composite. Rolling body is a composite of translation and rotation. So you should mark both the translational velocities and the rotational velocities when considering about a rolling body. So to draw it, I'll take 4 points on a circle and draw the translational velocity components separately and the rotational velocity components separately. So this is for the translation motion. Translation. Take this one V. This point is to the topmost point. That is V. And this point is V. So this point on this side and this point on this side is V. So this translation. And for the rotation, I will not draw the angular velocity, I will draw the tangential velocity. If it is rolling in this direction, it should have a velocity in this direction. If it is rolling in this direction, it should have a velocity in this direction. Because it is moving like this, moving like this. This is here, and velocity. So I say that a rolling body is a composite of translation motion and rotational motion. So we superimpose all these velocities in one object as we have described, as we see in real world. So this is V, this is V, this is V, and this is V. This is by rotation and translation motion, right? This is by translational motion. And by rotational motion, we have again a V here, a V here, a V here, which is moving in this direction, and a V here. So, the final theory is that an object here V is equal to 0, here V is equal to 2V, V is equal to root 2V, velocity I take this something you use, something is complicated for you otherwise. And here again you plus 2. Right? Just taking the resultant of this force, resultant of these velocities. So for an object that is moving in this direction, it is clockwise direction. An object comes to rest at the point of contact of the object, and the point of contact of the object with the surface. An object has the highest velocity, the topmost point, and so is not horizontal, it's actually this side. Right? Just happen this side. Right? So an object comes to it, rest at the point of its contact with the surface. An object has the highest velocity at its top point, and object has some velocity that is between the maximum velocity it can reach and the minimum velocity it can reach at the other points in surface. So this is the end of the theories of rotational motion, and I will see you probably in the next video with some examples on rotational motion for the theories we have discussed so far, and I will work it out with you. Thanks for watching. See you again.